Hello! For today's video project experiment, the title is Motion on a Ramp, and my name is Alison Tea, and this project is for Bellevue College for the class Physics 114 for Professor Dr. Azita. So for this video project, I would like to begin with some research questions. So the first one is, how does the weight of a toy car affect its velocity time graph when going down a ramp? The second one is, can you use Logger Pro's video analysis to draw conclusions about the relations between weight of an object and its velocity? So to get started, the materials I used during this project are 3 toy cars of different weights, a meter-long ruler, a box to use as a ramp, a phone to record videos, and the Logger Pro program. I also attached a photo to give a visual representation of the materials and so that we can see what the setup looks like. So as you can see, there are 3 toy cars and I labeled them car A, car B, and car C to help differentiate them as we move along this project. For our knowns, it would be the weights of each toy car. So for toy car A, the weight is 1.05 kilograms. For car B, the weight is 0.68 kilograms. And for car C, it is 0.25 kilograms. And car A is the heaviest, car B is the second heaviest, and car C is the lightest. So here I attached a video of car A going down the ramp, and I will press play right now. So there's that. Oops. Now this is car B. And now for car C. Now, for the next step, I used the Logger Pro program and I used its video analysis feature in order to analyze the velocity time graphs. So for car A, after I inserted the video onto the program and used the video analysis, right here we can see the velocity data points. So for this graph on the right hand side, it's a linear fit. However, on the left hand side, I used a better curve to best fit the data points for the velocity. And as you can see, the velocity is positive as its data points are above the x-axis. This also means that the acceleration is also positive. Now moving on to car B, similarly, I use the video analysis program from Logger Pro, and these were the data points I got for the velocity time graphs. Again, on the right hand side, this is the linear fit. However, the linear fit did not really best fit the curve, so I used this curve as it was a bit closer. And again, the velocity is positive as it is above the x-axis. This also means the acceleration is also positive. For car C, after using the video analysis to measure out the data points, so on the left-hand side, again, this is the linear fit used, and this is the best fit for the curve, which was kind of better than the linear, as the linear did not really fit the data points. And I could tell that there was a common trend because car A, car B, and car C, they all have a positive velocity and a positive acceleration because the data points are above the x-axis. This then allowed me to make the conclusion that car A, car B, car C all had a lot of similarities shared between them, such as a positive velocity time graph, a positive acceleration, non-uniform motion, and their graphs all looked very similar as well despite their differences in their weight because they all had that upward curve. Moving on to the assessment, these results make sense because an object's weight would not affect the velocity due to gravity. The only force acting upon it was when going down the ramp. The three cars were not pushed down the ramp, which confirms that gravity was the only force. There were no other variables such as air resistance to prevent gravity. And that is my video project. Thank you so much for watching and have a great day.